If you have already understood enough about the energy balance, pressure, temperature that we looked at, we'll add a few more details before we go into climate change in a bit more detail, and we will do that. So if you are very comfortable with these topics, then you can just skip to the sections ahead, but this is for kids who have never been taught, or they haven't seen these kinds of things before. So take your time, arrange your lessons in your own way, and this is on YouTube, so it's not going to go anywhere. We did the energy, and we mentioned winds. We said winds can go from ocean to land, land to ocean, down the mountain, up the mountain, and there are currents in the ocean as well. And we said energy gets moved around, which is why you get temperature distributions that we looked at. Middle East was very warm. India had partly colder temperatures than expected when we look at the long-term temperature anomalies. Remember, we defined anomalies. So let's look at the structure of the atmosphere and try to see how the atmosphere is organized and how the winds get set up, and how that is related actually to the Earth's rotation itself, and how we have to move energy. Never forget the basics you learn, because you remember that Earth is a sphere. It gets more energy from the sun than it sends back to space as thermal energy in the low latitudes, so there is excess energy, and at high latitudes it gets less energy from the sun than it sends as thermal energy to space, so there is energy surplus, energy deficit. We have constantly moving energy. We said this happens by winds, but how the winds are generated depends on the structure of the atmosphere and so on. Some of you may have again seen it, but seeing it again is not a bad idea. So we are looking at sea level here, surface. We are going in the vertical here. We are looking at miles and kilometers. So 6 miles, 30 miles, 50 miles, 300 miles, or 480 kilometers. That's height above the sea level. And you see some colors in the background with the surface, the ocean, the mountains, the clouds, and various other features that we also look at where the Hubble telescope is hanging around 370 miles or 600 kilometers above the sea level. And there are names of these layers of the atmosphere. Okay, the lowest layer where we live above the sea level is called the troposphere. These names come from Greek and they have meanings, and I won't go into the details. You can do it as homework. Troposphere, where does it come from? Stratosphere. For those who know enough English, you may know that stratified, stratus, and so on usually means layered. So stratosphere must have something to do with layering. Mesosphere is above that, from 50 kilometers to 80 kilometers. And meso means middle in general, mesosphere, so that's in the middle. And then you have thermosphere. Thermo usually refers to temperature, which probably means it's very hot, much warmer than what we have in the troposphere where we live and where we experience our climate and weather. Then you have exosphere, and not everything is a gas as we go up in the troposphere. We talked about nitrogen, oxygen, and the greenhouse gases like carbon dioxide, methane, nitrous oxide, water vapor, and so on. Stratosphere, we mentioned it as, well, I didn't call it stratosphere. I said in the upper atmosphere there is a place where ozone forms, and ozone absorbs high energy UV from the sun, which is damaging to us. So it's a good thing that it's getting blocked. So stratosphere has ozone, and then you have mesosphere. We almost never worry about mesosphere and thermosphere when we are talking about weather and climate. But ISRO, space agencies like NASA, European Space Agency, Indian Space Research Organization, they have to worry about it because the satellites have to fly through them, rockets have to fly through them and reach these upper atmospheres where they can less gravity, and so on and so forth. So there are aircrafts flying around at various levels within these as well. So if we zoom in to the lower part of the atmosphere and go again from sea level to 10 kilometer, 19, 31, 40 and 48 to 60 kilometers, here we are now, troposphere looking much more obvious with its mountains and clouds, and even the tallest Mount Everest is only 8.8 kilometers, and the troposphere ends at some point and it becomes stratosphere. There are details. You can find videos from NASA and NOAA and ISRO on these. You can follow up. And we talked about clouds forming, and there are strong clouds like thunderstorm clouds which can go up to 13 kilometers. So they are going right through the ceiling that we talked about before, like the ceiling of the room where the warm air from the pot with boiling water can rise, and then it has to go along the roof and so on. Passenger planes are flying around at these latitudes to minimize the air density, which increases the drag. So if you're running, you can feel the wind, or if you're riding a bicycle, or if you put your hand out of the window in a car, be careful. You can feel the wind. So if the wind is strong, you feel that your hand gets pushed strongly, so this can affect the airplane, so we worry about those things. And here is the ozone layer, and there are many things flying around like the weather balloons, which can fly typically around 18 to 13 kilometers, and then some military jet aircrafts can go as high as 35 kilometers. But the other thing that happens as we go up from the surface to these altitudes is that the pressure drops. So the temperature is warmest near the surface and keeps cooling till the troposphere's top, and then it warms again because ozone is absorbing the ultraviolet energy and getting warmer. But the temperatures cool from the surface to this top of the troposphere and then warms again. That's what we will have to worry about for weather and climate. But the pressure keeps decreasing and becomes almost zero as you go up to these altitudes of 480 kilometers and so on. We mentioned that before. As the air parcel rises, it expands because there is less pressure, if you remember your chemistry rules. But if you are not taught yet, don't worry about it. Imagine the balloon going up. If pressure is less, the air begins to expand, the balloon will expand, and so on and so forth. So all that happens here. So most of the weather is happening in the troposphere. So pressure decreases, temperature decreases up to some level and then increases, and then does some ups and downs through the mesosphere, thermosphere, exosphere, and so on and so forth. Okay, so we will leave this structure of the atmosphere for now. Only thing you have to remember is that winds are also flowing. They are flowing, from ocean to land, so in the horizontal, or they are going up to the mountain and coming down, so they're also going up and down. And when air parcels rise, there is wind going up with it and wind coming down. So winds are going in every direction as well, and they are moving heat, and they're moving gases like CO2 and methane and water vapor and so on and so forth. And remember again that the strong relation between temperature and water vapor in the air, and always remember that warm air holds more moisture, cold air is drier. So if you go up the mountain or to higher latitudes, tropics are warm and humid, higher latitudes are colder and drier, and so on and so forth. Okay, so let's keep those basic things in mind. This is a short podcast, but it doesn't matter. You want to get familiar with these concepts of the atmospheric structure. Ocean also has a structure as you go down. As you can imagine, ocean near the surface probably is warmer because sun is heating it, and then as you go deeper, the temperatures begin to cool down. And unlike the atmosphere where the pressure begins to decrease, the pressure begins to increase as you go into the bottom of the ocean, because more and more water is on top of you as you go down. water is very heavy, so pressure will keep on increasing as more and more water is above you. Same thing happens in the atmosphere. As you go up, less and less air is above you, so pressure gets less and less. Okay? At the sea level, what do you have? Both the ocean and the atmosphere. See the sea level pressure at the surface. But remember, the surface is not flat. You go up the mountain, then the surface pressure has to decrease because you are going up in the atmosphere and there is less air above. So that's why if you go very high, if you try to climb Mount Everest, oxygen begins to drop because there is less and less air and less oxygen, and you will have trouble breathing. Some people end up being sick. It's called altitude sickness, right? So also, if you dive into the ocean, unless you have a helmet and a diving suit to protect you, and of course breathing apparatus, remember scuba, right? Scuba diving, you might have heard of it. You can Google it also and look it up, and it's an underwater breathing apparatus, scuba. So all these things are important for how currents move in the ocean, air moves in the atmosphere, heat moves with them, and how it creates weather and climate. Okay, so we'll come back and look at how the winds are. We won't be able to explain all the details because it's very mathematical, it's very difficult, but if you just remember approximately how the winds are, then you can always look at where the winds are coming from depending on where you are, in the tropics, in mid latitudes, high latitudes, on the mountain, and so on and so forth. So see you in the next podcast then. Okay.